Welcome students, this is Chandan Singh Negi. In previous sessions we have discussed the domain and range of the functions, and today we are going to solve some more problems. Like first problem is find the domain and range of the function fx is equal to, this is, and if I just write this is 5 minus x upon x minus 5, right? So that is the we have to find out the domain and range of the function. This is 5 minus x upon x minus 5. And second question, this is checking, this is find domain of the function. Domain of function this is fx is equal to, this is under root 2x plus 3 upon x minus 1. That is, we have to find out the domain of this function, and here we have to find out domain and range both in functions, right? Check the solution number. This is first solution. Fx is given. This is fx is equal to, this is 5 minus x upon x minus 5, right? And first, in case of domain, numerator could be 0, but denominator must not be equal to 0. The first condition is the denominator is not equal to 0. The denominator is not equal to 0. So that means this is x minus 5 is not equal to 0. So this implies that x is not equal to 5. If I put this 5 on the right hand side, then it will be plus 5. So x is not equal to 5. We have domain is equal to r minus 5 or minus infinity to 5 and union 5 to positive infinity. That has to be an open interval because 5 is not included on that. Okay, see, for the range we need this one. For the range, this one, this is 5 minus x upon x minus 5. If I put x is equal to 5, that is the 0 by 0 form. And if it is 0 by 0 form, now look this one, the 5 minus x, if I take minus as a common, then it will be x minus 5 whole divided by x minus 5. Then x minus 5 is cancelled out. This is equal to 1. So now this is equal to 1, minus 1. If you put apart from x, apart from the 5, then we will get the answer is minus 1, right? So the answer will remain minus 1 if I put anything except 5. So that means the range is equal to minus 1. The range is equal to minus 1. That is the solution of this one. Now, the student check the second part. We have the second part. We have to find out the domain of the find out the domain of the function. That is question number 2. See this one. This is fx is equal to under root 2x plus 3 divided by x minus 1. For we have discussed if the problem is under root x upon under root y, under root x upon under root y, or under root x upon y, then whether the x must be positive and y also must be positive, so that the answer must be positive, will be positive. Or if x is negative and y is negative, then answer will be negative. Positive. So that means here, because it is in a square root, it must be positive. And here we will solve it for the domain only. For the domain, check it. I just writing this one. First, draw a line, number line, and check it. The critical point, I'm calling it, this is critical point. This is x minus 1 is equal to 0, then x is equal to 1. That means if I cannot put x is equal to 1 because it is undefined case. Then x is equal to 1. This is the first point. And now check the numerator where it is 0. Then the 2x plus 3 is equal to 0. Then 2x is equal to minus 3. And then x is equal to minus 3 upon 2. Now, that is the second point where it is 0. That is numerator is 0 at x is equal to minus 3 by 2. This is x is equal to minus 3 by 2. So here we have 2 points. And how many intervals are there? Just check this one. Understand, students, we have to find out the interval, right? So interval is, see this one, this line is to infinity. The first interval is this one. That means minus infinity to minus 3 by 2. And second interval is we have minus 3 by 2 to 1. Right? I can put my x equal to minus 3 by 2. Where if I put my x equal to minus 3 by 2, the numerator is 0. And it does not problem for not creating the problem. Right? But I cannot put x equal to 1. That is open interval. Whereas this is open interval and that is closed interval. See, that is open interval and that is closed interval. And second, this is the first interval, second and third interval is this one. That means x to infinity. Now check it. If I put x is equal to less than minus 3 by 2, or less example, if I put x is equal to minus 5. If I put x is equal to minus 5 in both the case, that is equal to, it is 2 into minus 5 plus 3 divided by minus 5 minus 1. This is equal to minus 10 plus 3 minus 7 upon minus 6. Minus cancel out, this is positive. Yes, I can put minus infinity to minus 3 by 2. Minus infinity to minus 3 by 2. Minus, this is minus infinity to minus 3 by 2. That is closed interval which we have discussed. Right? Next, now put x between minus 3 by 2 and 1. Any point, any number between minus 3 by 2 and 1. Put any number. Like I am just going to put the x is equal to 0. So if x is equal to 0, I just put this one. It is 2 into 0 plus 3, 3 and 0 minus 1 minus 1. So that whole is negative. That means minus 3 by 2 to 1 is not the solution. It is not the part of domain. And third one, check, this is 1 to infinity. Any number, 1 is not included. So I is putting this x is equal to 2. If I put x equal to 2, so 2 is 4, 4 plus 3 7 and 2 minus 1 1. That is positive. So that if I put this is x is equal to 2, that is 2 into 2 4 plus 3 divided by 2 minus 1. That is equal to 7 by 1. This is under root 7. That is a positive. Under root 7 is positive. Yes, this is the solution also. That means 1 to infinity is also the solution in open interval. Okay, now this, understand this. What is the domain here? This is domain. Domain is now, this is minus infinity to 3 minus 3 by 2. And that gap is not included in domain. And then add this one. We cannot, we generally do not write this is plus in terms of domain or in terms of interval or in terms of the sets. Okay, see, what should I write here? So I will write this is minus infinity to 3 minus 3 by 2 and union 1 to infinity. So that is the domain of the function. That is the domain of the function. The domain is minus 3 by minus infinity to minus 3 by 2. That is a closed interval. I'll just check this is closed interval. And union, this is union 1 to infinity. Right? Thank you, students. Thank you. And next sessions we will solve some more problems. Thank you.